Dawn breaks over the Sea of Azov at 05:30 hours. A Russian Bayern M corvette loaded with 8 deadly Kaliber cruise missiles prepares to unleash devastation on Ukrainian cities. The crew believes they're safe, protected by layers of advanced defense systems. They're about to discover how wrong they are. 7 Ukrainian combat drones slice through the morning air, invisible death approaching at breakneck speed. The lead Rebecca drone accelerates to 400 kilometers per hour as Russian checkpoint guns suddenly erupt in thunderous gunfire. Bright tracer rounds illuminate the sky like deadly fireworks. Each 23-minute shell carries enough explosive power to instantly vaporize a drone. The checkpoint gunner can't see his targets, but the distinctive whine of electric motors gives them away. He fires blindly at the sound, walking his rounds through the air in desperate patterns. The lead Rebecca pilot yanks hard left as explosive shells detonate mere meters away. The drone pushes beyond its limits, 432 kilometers per hour, screaming past the gun position before it can track the target. But the damage is done. Gunfire alerts every Russian position within 10 kilometers. Telegram messages spread faster than military radio networks. The element of surprise vanishes in seconds. The operator's screen suddenly fills with static as invisible power lines appear from nowhere. The drone pulls up sharply, clearing 110,000 volts of high-voltage electricity by just 2 meters. Every instrument goes haywire, compass spinning wildly, video feed flickering like a broken television. For 3 agonizing seconds, the pilot flies completely blind. Then a massive radio tower emerges from the darkness. The operator banks hard left, missing the guy wires by mere inches. Death lurks everywhere in this electronic battlefield. Behind the lead Rebecca, 2 more drones follow 30 seconds apart, using the chaos to slip through undetected. These are specialized hunter-killers designed to blind the warship's radar defenses. Their mission is critical. Without them, the main assault will fail. 4 Bober drones take the northern route, flying slower at 200 kilometers per hour but carrying devastating heavy warheads. These are the hammer that will strike after the Rebeccas clear the path of destruction. But those telegram warnings have already reached the next checkpoint. A Repellent 1 electronic warfare jammer waits in ambush, flooding control frequencies with 400 watts of electromagnetic interference. The lead Bober's screen goes black, signal completely lost. The Ukrainians anticipated this electronic assault. Pre-programmed waypoints automatically activate. The drone switches to autonomous mode, navigating by accelerometer and optical landmarks, flying blind through the electromagnetic storm like a digital ghost. 3 minutes later, the video feed mysteriously returns. The Bober is exactly on course, testament to Ukrainian engineering excellence. But ahead, a BTR-82 armored vehicle blocks the highway, its machine gun already firing predetermined patterns of destruction. The operator dives into an industrial zone, using concrete buildings to break the line of sight. Those same buildings shelter Russian soldiers who pour out like an anthill kicked over when they hear the approaching drone motors. The drone maintains 10 meters. Altitude, a crucial height where Earth's curvature creates radar shadows. A hilltop radar that detects targets 50 kilometers away at high altitude can only see 12 kilometers when you're skimming the ground. Physics becomes their invisible shield. The drones thread through invisible corridors of safety while soldiers fire at sounds and glimpses. But statistics don't lie. Concentrated fire from a coordinated squad finally connects. The third Rebecca spirals into a parking lot, its warhead detonating on impact in a massive explosion. 2 Bobers and 2 Rebeccas remain. They cannot afford to lose any more assets. The lead Rebecca crests the final ridge. The operator's screen fills with something that shouldn't exist according to intelligence reports. The mission briefing was catastrophically wrong. In 4 seconds, he must make a split-second decision that will either save the entire operation or destroy every remaining drone. A Pantsir air defense system launches 6 missiles simultaneously. These aren't ordinary surface-to-air missiles. They're Pantsir anti-drone interceptors, developed specifically after commercial. Quadcopters humiliated Russian air defenses in previous engagements, Each missile weighs just 12 kilograms but carries 200 tungsten spheres in a fragmentation warhead designed to create a donut-shaped kill pattern specifically for small UAVs. The spheres expand outward at 1/800 meters per second, creating a lethal cloud 10 meters in diameter, more than enough to obliterate these drones. The Pantsir operator uses ladder engagement tactics, launching missiles at staggered altitudes, first at 50 meters, second at 30, third at 10 meters, forcing the drone to fly through at least one fragmentation pattern. The fire control system calculates intercept points based on current trajectory, creating a three-dimensional box of death. Each missile's proximity fuse sends out radio pulses, waiting to detect enough metal mass to trigger detonation. But the Rebecca's operator studied Pantsir engagements extensively. He knows these missiles have a critical vulnerability, a 1.2-second arming delay after launch, a safety feature preventing warhead detonation too close to the launcher. At 432 kilometers per hour, the drone covers 144 meters in those crucial 1.2 seconds. The moment he sees missile launch flares, the operator pushes the stick forward, diving straight towards the Pantsir system. The missile streaks overhead, its proximity fuse still disabled by safety protocols, unable to detonate even as the drone passes within meters. By the time the missiles arm, the Rebecca is already below them, using the launcher's own safety systems as a protective shield. The operator levels out at 5 meters and lines up on the Podlet K1 radar, the electronic brain providing targeting data to every Russian launcher within 200 kilometers. The Pantsir's twin 30mm cannons open fire, each barrel cycling at 5,000 rounds per minute. The gunner attempts boxing tactics, creating rectangular zones of death where the drone should be. But the fire control solution needs 1.5 seconds to calculate, 0.5 seconds for servo motors to aim, then 1.5 seconds for rounds to travel 2 kilometers. Total lag time, 3.5 seconds. The drone operator changes course every 2 seconds, ensuring the computer is always solving an outdated targeting problem. The Rebecca punches through the defensive fire and slams into the radar antenna. The shaped charge detonates, creating the Monroe effect, an explosion that crushes a copper cone into a hypersonic jet moving at 7,000 meters per second, not melting the metal, but deforming it under such extreme pressure that solid copper punches through armor like a needle through paper. The molten jet punches through the antenna array, the processing units, operator stations, and out the back wall, finally dispersing into copper spray. The second Rebecca targets the P-18 spoon rest early warning radar. The Pantsir switches to thermal imaging backup, but dawn creates temperature inversion, cool air trapped under warm air. This causes thermal shimmer and false heat signatures as air layers mix. The drone's electric motors generate minimal heat signature, maybe 10 degrees, Kuhn, above ambient temperature, against the warming morning sea that still retains yesterday's heat. The drone appears as a cold spot, then disappears entirely when flying over cooler land patches. The thermal imager's processing algorithm, designed to track jet engines at 600 degrees, cannot maintain lock on such a small temperature differential. The Pantsir gunner fires in desperation mode, predetermined spiral pattern starting at the drone's last known position and expanding outward. This water hose technique might work against helicopters that cannot change direction instantly, but the drone can pivot 90 degrees in half a second. 5,000 rounds expended. 0 hits achieved. The Rebecca strikes the P-18 dead center, eliminating 200 kilometers of radar coverage instantly. With both primary radars destroyed, the corvette 4 kilometers offshore loses its early warning network. Without the Podlet and P-18 providing initial detection and tracking, the ship's own radar can only see 40 kilometers, giving less than 2 minutes warning. The defensive shield protecting the corvette vanishes. The warship, preparing to launch missiles at Ukrainian cities, is now blind and alone. The corvette's radar detects incoming drones at 4 kilometers, ghost contacts that appear and disappear with each wave. The Russian ship faces an impossible problem: distinguishing 3-meter altitude drones from 2-meter ocean waves. Both create radar returns of similar intensity. Doppler shift that normally separates moving targets from stationary objects fails when drones fly at variable speeds between 80 and 120 knots. The computer's clutter rejection algorithm, designed to filter out sea spray, starts filtering out real threats. Every third radar sweep, the drones disappear entirely as the processor decides they must be false returns. The AK-630M2 duet system spins up with mechanical precision. 10,000 rounds per minute erupt from twin 30mm cannons. The fire control computer attempts path calculations using Kalman filtering algorithms, mathematical formulas that predict where moving targets will be by combining past positions with current sensor data. But the operators throw calculations off by making random course changes every 2 seconds. The duet system was designed to engage P-270 Mosquet missiles, 3,000-kilogram weapons flying predictable trajectories, not 150-kilogram drones maneuvering randomly. It's like using a sledgehammer to hit a hummingbird. The computer needs 3.5 seconds to generate a firing solution. The drones change course every 2 seconds. The mathematics never align. The corvette deploys its PK-10 decoy system, launching clouds of chaff, aluminum strips cut to half the wavelength of targeting radars. Each strip creates a radar return larger than the drone itself. Within seconds, hundreds of false targets bloom on every radar screen within 50 kilometers. Against radar-guided missiles, this creates impenetrable confusion. Against drones guided by human operators watching through cameras, it creates nothing but pretty sparkles in morning sunlight. The operators ignore the light show and maintain visual lock on their target. The corvette's TK-25E electronic countermeasure suite activates, pumping 200 watts across the spectrum from 20 MHz to 40 GHz. Against normal radio-controlled drones, this would sever control links instantly. But Ukrainian drones use frequency-hopping spread-spectrum technology, jumping between 128 channels per second in pseudo-random patterns known only to their operators. The jamming affects individual frequency hops, causing occasional frame drops and pixelation, but never blocks enough sequential channels to break the connection. Video feed quality degrades from 1080p to 480p, annoying but still perfectly usable. Sensing imminent destruction, the corvette captain orders evasive S-turns at maximum speed, but physics doesn't negotiate. The 949-ton vessel needs 15 seconds to change heading 30 degrees. The drone needs 50 milliseconds. The Rebecca operator recognizes the ship's evasion pattern and times his approach for the steady period between turns. At 500 meters, he switches to manual control. The radar mast fills his screen. 6 meters of critical electronics. The duet cannons cannot depress below -5 degrees. At 200-meter range and 3-meter altitude, basic trigonometry puts the drone completely under their firing arc. Sailors with PKM machine guns fire desperately from the deck, but they face an impossible challenge. The drone crosses their field of view in 0.8 seconds. Human eyes need 0.2 seconds to focus on moving targets, another 0.3 seconds to track them, and 0.2 seconds to aim effectively. By then, the drone has moved 100 meters. They're literally firing at after images burned into their retinas. The lead bobber aims directly at the ship's mast containing all radar systems, its shaped charge primed for total destruction. The captain screams for emergency launch procedures, desperately trying to fire the Kaliber missiles before his ship is crippled. But launch sequences require 2 minutes for gyroscope alignment, target validation, and missile warming. The bobbers are 30 seconds away. The first bobber slams face first into the mast. Instantly, every radar, communication suite, and data link aboard the warship goes completely dark. No longer able to fire their cruise missiles, they've become a sitting duck. The second bobber dives toward the corvette's port side at 30 degrees, its operator aiming for the junction between frames 44 and 52, where the missile magazine sits behind 15 millimeters of steel plating. If successful, the resulting explosion will detonate the Kaliber missiles in their vertical launch cells and transform this warship into a fireworks display. At 100 meters, the operator makes final adjustments accounting for the ship's 8-knot drift and 3-degree list from hard maneuvering. The shaped charge must hit at exactly 90 degrees for maximum armor penetration. Too shallow and it deflects harmlessly. Too steep and it wastes explosive energy. The operator practiced this exact moment 500 times in simulation. But reality includes variables no computer program captures: hands shaking from adrenaline, sea spray on camera lenses, and the knowledge that missing means Ukrainian friends will continue suffering under Kaliber bombardment. The Bober strikes exactly at the missile magazine's forward bulkhead. Its shaped charge, a copper cone surrounded by high explosives, creates the Monroe effect once again. Detonation waves focus into a jet of molten metal moving at 7,000 meters per second. The 15mm steel plate offers the same resistance as tissue paper. The hypersonic jet punches through, spraying molten copper across stored ammunition and missile components. The second Bober strikes missile handling equipment connected